students, we are going to see the differential calculus in a 3-dimension way. In a 3-dimension way means the sense it is not in 3D factor. Simply I am just joking with you. There are 3 aspects of differentials. One is limits, continuity and differentiability. There are 3 aspects. Now we are going to see the last and final part of differentials. That is, first part we could see as limits, second one continuity and third one is differentiability. What is differentiability? That differentiability, it is almost you might have learned about each part as f dash of x. In every part you have learned about f dash of x. Now a function f is said to be differentiable in closed interval a comma b if it is differentiable in open interval a comma b and at the end points of a and b. End points means that is lower limit as well the upper limit a and b. Now f dash of a is the lower limit here. F dash of a is the lower limit, that is limit delta x tends to 0 upon 0 plus f of a plus del x minus f of a by del x. This is f dash of a, this is the lower limit f dash of a, and limit h tends to 0, this is a very small increment. Del x is nothing but very small. For example, 2 if I consider the 2.00000001, this is considered to be h. Remember that this point only, that h is 0.0000 even 1. Like this very small increment only they consider as del x. So you should know about all that. So this is a definition. Just I recall this one. For this problem I need this definition. That is the reason why I have taken into consideration of what is differentiability. That is, for the lower part f dash of a, limit delta x tends to 0 plus f of a plus del x minus f of a by del x, and f dash of b and limit delta x tends to 0 minus, remember that here 0 plus, here 0 minus, f of b minus del x minus f of b by del x. Remember that these two part we have to consider here. Here it is right to the limit of a, here left to the limit of b, here right to the limit of a, here left to the limit of b. That is the reason why here it is minus, there it is plus. So these are the two things you must remember. So h tends to 0 upon minus. So f of b minus h minus f of b by h. So determine whether the following function is differentiable at the indicated values of values. That is the first problem in that is problem number 3 in exercise 10.1. The function is given x into modulus of x. Modulus of x, as you know, it is a very fantastic sum. So modulus means it is on the side which is or negative as well positive, both sides are there. First of all, we have to define about the function f of x. Let us think about it. What is f of x? So first the f of x I can consider, first the function we can define. I am not going to see this part here. First the function we can define for x into modulus of x. X into modulus of x, there are two kinds of value for modulus of x. So one is x into plus x and x into minus x. When do you get plus x? When do you get minus x? That means modulus having both ends, but we can take one end for the value when it is to be. So x into minus x if x less than 0, remember that. X into plus x, that is here if x greater than or equal to 0. There are two cases I have considered here. One is minus x, next one plus x for modulus of x. So that means in this case here the function is defined minus x square and then plus x square if x less than 0, if x greater than or equal to 0. Now this function involved with two things, one is less than 0, other one is greater than or equal to 0. That is the function we have defined here now. Now, based on this differentiability, we are going to solve this problem. So, what are the limiting points that we have to think of it? Here 0 is the point here. That means 0 plus and 0 minus, that is what I am going to think of it here. For that, that is left limit as well the right limit. Let me take the part of left limit, L of f dash of 0. So, limit here h, here this part here minus x square plus x square. Let me define about the concept of limit L of f dash of 0 here. L of f dash of 0 here, what is that here? X tends to, here x only is the value, x tends to here 0 minus f of x minus f of 0 by x minus 0. Remember that. How the function is defined based on this principle of that is f of x minus f of 0 by x minus 0 here, that is a function here. That means f of x is what? Here limit x tends to 0 upon minus. F of x we have defined for that limit, left limit means we must consider only for less than 0, I am sorry, less than 0 here, x less than 0. So, that means minus x square. So, we consider as minus x square. In the place of f of 0, it is 0 square by x, that is this part x as it is. So, if I cancel it, what happen? It is minus x. So, everything will go limit x tends to 0 on minus. So, that means anything the value of 0 do not have plus or minus. So, 0 only, the result number 1. Now, let me take right hand side part of it, r of f dash of 0. Here what is the limiting point? Those things you should remember. Here x tends to 0 upon minus. Now, limit x tends to 0 plus, remember that 0 plus right limit. So, the 0 towards this direction, 0 is the part. Now, it is right limits mean this side and left limit mean this side. That is the reason why this is 0 minus, this indicates 0 plus. In this way only we have to define it, 0 towards right and 0 towards left. I have completed this part first. Now, I have taken the second part. So, remember that. Now, f of x minus f of 0 over x minus 0 here. So, let me take this part. Now, f of x is x greater than 0, that means here this function exists. This is the function exists for that. First part we have taken minus x square and second part we take the other one. So, that means limit x tends to 0 plus x square minus 0, because x square 0 square is what? 0 only, x minus 0 x. So, now x and x getting cancelled, this and this, finally limit x tends to 0 plus x. The place of x substitute 0, so here 2. So, from 1 and 2 what do you understand? We infer that f is differentiable at x is equal to 0. Remember that. If both value we have got the same answer, L of f dash of 0 equal to r of f dash of 0. If I get this, that means f is differentiable at x is equal to 0. That means whether it is a differentiability or not, that is a question they asked, whether it is a differentiability or not, that is a question. So, it is differentiable at x is equal to 0, because both value indicate the same answer, that means this is right. Very simple, easy one.